In the scene that I am evaluating, the coyote is trying to push a cannon off a cliff and hit the roadrunner. As the roadrunner approaches, the coyote pushes the cannon off the edge. The cannon completely misses the roadrunner, but keeps traveling up to the other side of the mountain. It keeps going up and up until it eventually comes back down on the other side of the mountain where it squashes the coyote. Using physics terminology, this specific scene would not work because it does not follow the conservation of energy. The total energy of a system is never changed but conserved. The cannon should have converted its potential energy to kinetic energy by the time it came to the ground, but it kept going and going until it came all the way back up to the coyote. To start, I googled the average height of a coyote, and the result came up as 30 inches. This being so, I was able to see how tall the mountain was using the coyote as a scale. Using this scale, I was able to see that the height of a mountain where the cannon was dropped was 150 inches, which is 3.8 meters. Also using Google, I was able to see that the average weight of a coyote is 30 pounds, which is 13.6 kilograms. The mass of the cannonball was easy to find because I used my scale to see that it was about 0.25 meters, which makes the mass of the cannonball using iron 19.1 kilograms. Now I figured out that the potential energy the cannon had at the very top before it was pushed off. Using the formula of potential energy is equal to mass times gravity times the change in height, I plugged in my information and was able to find out that the potential energy at the top of the cliff was 725.8 joules. At this point, the cannon had a potential energy of 725.8 joules, a velocity of 0 meters per second, and the kinetic energy of 0 joules, a height of 5.6 meters, and a total energy of 728.8 joules. To figure out how this would be impossible, I had to determine the potential energy at the top of the other side of the cliff, which the cannon goes to. Using my scale of 30 inches, I was able to see that this side of the cliff was 5.3 meters, which is almost twice the size of the other side of the cliff. Just using how tall it is shows that it is impossible for the cannon to make it up all that way due to the conservation of energy. Using the potential energy formula, I filled in my knowns, and I was able to see that the potential energy of the cannon at this point was 286.5 joules. This proves that the physics would not work because it is impossible for the cannon to start from a lower point and not conserve its energy as it gets higher. Conservation of energy means that all energy is conserved before and after an event. In this case, it does not happen. So therefore, the physics in this particular scene does not work and it is unrealistic.